We are picking up right off on the previous video, and that video is just a general overview. If you need some of the basic definitions I'm talking about, please go back and view that, but it's not necessary. This is pretty straightforward. So in sketching polynomials, what we really want to happen is to have this in factored form. And this one is in factored form. It's broken down to its components. And we want to then analyze what's going on with each of these. So the first thing we want is we want the degree of the polynomial. And that's simply going to add up all these right here. We got 3 plus 1 plus 2 plus 2, 4, 5, 6, 7, 8. So we have an 8th degree polynomial. Okay? And we want the highest order term. And all that is that we're going to take the negative 3 times the 1 times the 2, but we got to do it twice because that's raised to the second power, and then times the 1. And you can usually do this in your head. You don't actually have to write this out. That's going to be 4 times the negative 3, which is negative 12. All right? So basically what we have is a negative 12x to the 8th power. And that's going to come in handy when we want to look at end behavior for this, but we don't need to be too concerned over the stretching, compressing factors that this may happen. All right. Next thing we want to do is kind of get an idea of how many terms we're going to have. Well, in a polynomial, the rule that we said was going to be n minus 1 at most. So it's going to have at most 7 terms. It can have quite a few less. It could be really stretched out. If it was like an odd one, you won't see that many terms. An even will always have a turn, at least one turn. All right. So next thing, zeros and multiplicity of those zeros. All right. So what we're going to do is we're just going to write our first x's. Well, the first one is easy. X is equal to 0. And we have a multiplicity of a 3 on that. So we have multiplicity of a 3. The next one is going to be x minus 2. So x is going to equal to 2. And that just has a multiplicity of 1. And I write it with a little m with a number right there. And then we have 2x plus 3, so I'm going to subtract 3 and divide by 2. So I have x is equal to negative 3 halves. That has a multiplicity of 2. And then my next one, I have x minus 4, so I have x is equal to 4. And that has a multiplicity of 2 as well. If I were to add these up, I better get 8. 4, 6, 8. Okay, that's my degree. End behaviors. So first thing we want to recognize is, do we have an even or an odd degreed polynomial? We have an even. So that's very useful. I'm going to go back to what I remember from quadratics, in that if the a is positive, the leading coefficient of positive opens up. If the leading coefficient is negative, it opens down. So what we want is, as x approaches positive infinity, my y, my f of x, will approach what? Well, since its a leading coefficient is negative, it's also going to approach negative infinity. Some teachers allow you just to write simply down. Okay? As x approaches negative infinity, we're going down the other side of the x-axis this way, y also approaches negative infinity. It opens down. And of course, a lot of teachers, including this one, will allow you to write down. Right? Okay, so let's get into a couple more examples and I'll get this going, but I do want to cover this first. Okay, generally steps. All right, there's other ways to, as we say in East Texas, skin a cat, and there's other ways to sketch a polynomial. But I think this is one of the most straightforward ways, and it's pretty universal. I've seen this in college, high schools, all over the place. First thing you want to do is find the zeros. The zeros are where it crosses the x-axis. So this is the x-axis and the y-axis. Then the multiplicities, and then the end behavior. Graph the zeros, then graph the end behavior. So we would graph these zeros right here, then we would graph the end behavior. Here we have an even function, it looks like, with a leading coefficient of a is positive. So we have, as it goes in positive infinity this way and positive infinity this way. Then we want to determine the multiplicities. Now this is a big deal. If the multiplicity is even, it is tangent. And this right here means that we'd have something like, this is 1, 2, 3. So we would have something like this in our factored form, x minus 3 squared. That's an even multiplicity. It could have been a 4. We don't know. So it just kind of bounces. Some teachers use the word bounce, some use touch, some use tangent. I tend to use the word tangent, all right? If it is odd, it will cross. It will either cross straight away or it will wiggle. Now for our purposes, this wiggle, we can put it as an x cubed, all right? This could have been an x to the first, but our purposes, if it has greater than x to the first, if it's a greater degree and it's odd, we'll just create a little wiggle. How does this work in an example? Here we go. Here we have this in factored form already, and we're just keeping simple roots, -2, 1, and 3. And here I have x plus 2 to the third power. That makes my 0 x -2. It's to the third power. It will wiggle, and the multiplicity is 3. All right. So I would graph this, this, and this first. I would then do my end behaviors, because this is a 6-degree polynomial, 3, 4, 5, 6, and with a being positive, we know that the ends are going to be up. So I would just graph this first, and I would graph this first. All right. Next thing is I have x at -1. I know that x is 1, and it's a first degree, so it's just going to simply cross. It's going to shoot straight through, almost like a linear. And then at x3, it is tangent because the multiplicity is 2, and it just bounces. So it just goes up and down, or down and up. All right. So let's take a look at this one. So I have a leading coefficient of 2, and I want to find my degree first. So I have 1, 2, 3, 4. So it's a 4th degree. All right. It's a 4th degree polynomial, and it's going to be 2 times 1 times 1 times 1. So it's basically 2x to the 4th. All right. I'm going to now plot my zeros. I'm -2, 1, and 3. So there's -2, 1, and 3. Next thing is I plot my end behavior. So I'm going to go up, okay, and I'm going to go up. This is a technique. You don't have to do it this way. Alrighty, so now it looks like it just bounces at 1 right here. It's just going to bounce. It's going to come and bounce, and it's going to go back up. Okay. Oh, crosses at 1. I'm sorry. Nope. Let's go ahead and write this in. So -2, it just crosses. Okay. And it has a multiplicity of 1. At 1, it is tangent and a multiplicity of 2. And at 3, it is crossing 1. So there's no curve. So what we're going to do is we're going to come in. We're down below. We're already below the graph. And we're going to come in and we're going to bounce and then turn and go back up. So it's going to look like this. Bounce and back up. Okay? Something like that. Okay? I didn't quite, it should be a little prettier of a bounce, but I'm not quite there. Let's do one more example, then I'm going to show you some of the answers on the other ones. So what we have here is we have at -2, we have a multiplicity of 5, and that's going to wiggle. All right. At 1, it's going to cross, a multiplicity of 1. And at 3, it's going to cross, and I have a multiplicity of 1. Okay. It's a 5, 6, 7. So, and all the leading coefficients is going to be 1x to the 7th power. And, I'm sorry, I should have put up and up here. All right. So now we have a odd. Now remember, when we memorized our odds, I always referred back to the cubic, where I'd have something like this or something like this. Okay. This would be positive leading, and that would be a negative leading. So this part is going to be down. That part's going to be up. Down and up. Okay, because as x approaches negative infinity, y will also approach negative infinity. So let's go ahead and plot our points. 1 there, 1 there, and 1 there. Okay, and we got to figure out what's going on here. So I'm going to first plot my end behavior. So I'm going to go down, and I'm going to go up, and I'm going to join them. They're just going to cross. So I'm going to come and cross and go back up. So just nice, smooth cross like that. Okay, you're going to want to practice this. So let me pause and fill out some ones on the next page so you can look at these. But go ahead and try and do these on a scratch piece of paper real quick, and then you can check your work here after you undo pause. So pause now.